Okay, so for our final lesson in Algebra 1, this is it. We've reached the end of the road. We are going to simplify fractions containing radical expressions. And this is also the end of our study of square roots. It also happens to be the trickiest part of all of this. So, but all the practice we've done has us well prepared for this. So let's just jump into it here. And here's what I mean by a fraction containing radical expressions. Here's a good example. Root 8 over root 6. And we have to ask ourselves, how do we simplify a fraction like that? Because it's not as simple as saying 8 over 6, which would be 4/3. These radical signs make everything a little bit more complicated, as we've seen. So let me just jump into it. I'm going to use this one as an example here. And here's what you have to know. This is really what you have to do in order to simplify a fraction containing radicals. It says here, to simplify a fraction containing radical expressions, we must, in quotes, rationalize the denominator. In other words, our denominator down here cannot contain an irrational number. That's sort of the rule for algebra here, is that if you have an irrational number in the denominator, it's not simplified. It's okay if we have one up here, because root 8 is an irrational number. I'm not too concerned about this, but I need to get rid of this root sign in the denominator. Anything down here is fine, so long as it isn't an irrational number. Now you might be wondering, well, how the heck are we going to do that? We use a little trick, and here's how it looks. I'm going to multiply this fraction. Ready? I'm going to multiply it by 1, but I do so in a clever way. I multiply it, both the numerator and the denominator, by the square root of 6. So whatever's in the denominator, whatever I'm trying to get rid of, I multiply both the numerator and denominator by that. And this is really just a fancy way of saying 1, because root 6 divided by root 6 is positive 1. But here's why we do this. Ready? Okay, in the numerator, it's root 8 times root 6. So we combine what's inside the radicals, and we get root 48. We'll deal with that in a minute. And then down here, remember our rule, remember this trick we saw last week? Root 6 times root 6. Do you remember what that is? It's just 6. Whenever we square a radical, we get what's inside. So it just becomes 6. And now we've rationalized the denominator. So the only thing left to do is just to simplify. And we'll do that by factoring 48. You could do this several steps, but I know that 48 factors into 16 and 3. This is the quickest way to do it. And I'm not even going to touch the denominator yet. I'm just going to leave that 6. Okay, so 16 times 3, I can take out the 16, so I square root 16, that's 4. So this radical expression, the numerator, will simplify to 4 root 3 over 6. Now there's still one little step to do. We can always simplify coefficients. There's nothing I can do with the root 3. But remember, this 4 and 6 will reduce to 2/3. So this then changes. Our final answer is just going to be 2 root 3 over 3. And there you have it. There's our first example. Now I'm also going to do one of the tougher examples, because this is the one you might need to refer back to later. These get a little tricky. Okay, well, how do we rationalize a denominator when there's a binomial in the denominator? And the way we do this, again, we're still going to be using this little trick. We're going to be multiplying by 1, but we're going to do this in a slightly more fancy way. I'm going to multiply it not by 2 minus root 3. I'm going to use one of these little factoring tricks. This relates to factoring. We're going to multiply this by 2 plus root 3. And I'm going to do the same thing in the numerator, 2 plus root 3. 2 plus root 3. So I'm just multiplying it by 1 in this fancy way. And this is going to get rid of the radicals down here. It's also going to rationalize it. And the reason we do this is a very similar trick to whenever we factored a difference of squares. Because here's what happens. You'll see why this works. Ready? First of all, I'm just going to simplify this a little bit. For right now, I'm just going to write 3 times 2 plus root 3. We'll worry about simplifying that in a minute. 2 plus root 3. Let's leave that alone. Now remember, whenever we multiply polynomials, the terms in the first polynomial get multiplied by both terms in the second polynomial. So this is going to come out to be, well, I do 2 times 2 is 4. 2 times root 3 is just 2 root 3. So I'm going to write plus 2 root 3. And then I'm going to do negative 3 times 2. So now I distributed the 2, so now I got to distribute the negative root 3. Negative root 3 times negative root 3 times 2 is negative 2 root 3. And then finally, negative root 3 times positive root 3, it's just going to give us negative 3. Because remember, we're squaring a radical, so we just get the 3, the radical sign disappears, and it's a negative times a positive, so we're going to put negative 3. Now the reason why this works so nicely is because you'll see that the terms in the middle always drop out. Whenever you multiply a difference, this is just like a difference of squares. Whenever we multiply this positive 2 root 3 and negative 2 root 3, or the terms in the middle, will always drop out. So all we're left with is 4 minus 3, which is 1. Okay, and now we just have a little bit more work to do. Let's just simplify the numerator. We distribute the 3. 3 times 2 is 6. 3 times root 3 is 3 root 3. That's pretty easy. Just stick them together. And the only thing I'll do to simplify this one little step is I can get rid of the 1, because whenever we have a 1 in the denominator, we don't need to write that. So our final answer is just going to be 6 plus 3 root 3. And that's our final answer right there. Avoid the temptation to add 6 and 3. You might be tempted to think, well, isn't our final answer 9 root 3? No, it's not. Remember, a binomial like this cannot be simplified, because this is the same thing as saying 6 plus 3x. Remember, we treat this radical sign just like we would a variable. So it's like combining like terms. I can't combine 6 and 3x. I can't combine 6 and 3 root 3. So our final answer is just 6 plus 3 root 3.